Hi, welcome to my channel, where I share my knowledge on programming with Python and OpenCV. Today we're going to be performing facial detections using a Haar frontal face cascade to recognize our faces. Now, we're going to be doing this using two modules. One module which will be our entry point and include a function for performing our video processing using OpenCV. Our second module contains a class for our frontal face detector, which we will be going into details in this video. Now, without further ado, let's get started.
We'll start by looking at our Frontal Face Detector.py module, which is a part of our face detection package. Now, this module first imports OpenCV, OS, and NumPy. We use OpenCV and NumPy for our face detections, and OS we use to access our data files folder, which contains our Haar frontal face cascade. Past our imports, we define a class as Frontal Face Detector, and then some class constants for the font, text color, box color, and thickness, in which we will draw the rectangle boxes over our facial detections that were made successfully. After our class constants, we're going to initialize the Frontal Face Detector with a pre-trained Cascade classifier for face detection. To do this, we get the current file directory that we're working in. This will be our package. Now, with this, then we can go ahead and specify the path to our frontal face cascade using os.path.join with the current directory and our data files folder. Then we locate the Haar frontal face cascade.xml file in this data files folder. Now that we have the path to our Haar cascade, we're going to go ahead and create it as a part of this frontal face detector class using the cv2.cascade classifier method. Now, after our initialization, we have a method titled detect faces. This takes in a frame, which is NumPy array, and we will return nothing from this method. In this method, we use exception handling to ensure smooth operations. And in our try block, we first convert our frame parameter into a grayscale image as required by the Haar frontal face cascade to make detections. Now, with our grayscale frame, we go ahead and get a NumPy array with the values for faces detected by passing in our grayscale image and a scale factor and a minimum neighbors parameter. Now, I think it requires a little more attention on this line here, where we specify a faces variable and we set it equal to our self.faceCascade.detect multiscale. So, this self.faceCascade is an instance of the Cascade classifier class, which is a pre-trained model for detecting objects, and in this case we're detecting faces. Now, the method detect multiscale is specifically used for detecting objects at different scales in an image. So by scales I mean different sizes. Now, to go through each element, we already understand that the frame gray is our grayscale image, which by using a grayscale image we're simplifying the processing while we're still retaining enough information in our frame to make accurate face detections. Next, we have our scale factor, which we set to 1.2. This represents how much the image size is reduced at each image scale. So a lower value here will increase the detection time, but it will also increase the chance of detecting smaller faces in our video frames. Conversely from this, a higher scale factor value will speed up the detection, but we might miss smaller faces being detected in our frames. Now, with that being the scale factor, we also have this value of 8. This is the minimum number of neighbors a region needs to have in order to be considered a face. So this parameter works to filter out false positives. Increasing it will decrease the number of faces detected, but also reduce false positives. So, in summary, this line is calling the detect multiscale method to detect faces in the grayscale image. It uses scale factor of 1.2, which means it will progressively scale down the image by 20% until it finds a match. And then our third argument is the minimum neighbors, and which we specify as 8. And this indicates that an area must have at least 8 neighboring areas in order to be considered a face, to help reduce false positives. Now, the output of this faces will be a list of rectangles, where each rectangle represents a detected face's position in the frame. Now, for the XY coordinates and the width and the height detected in these faces, which we are found using our detect multiscale method, of our Cascade classifier, we're going to loop through the faces and get the XY coordinates of the starting point for this rectangle box, which will be the upper left corner of the rectangle drawn around the face. Now, the width and the height we use then to specify the ending point of this rectangle, which would be the bottom right side of the box drawn around the face. Now, you can see that for each face, we're going to go through and we're going to draw a rectangle on the frame by first specifying that start coordinate and the end coordinate by adding our width and height of the rectangle to our starting coordinates. Lastly, we're going to use our constants to specify the box's color and the thickness of the lines to draw it with. Outside of our loop, we can update the number of faces detected by specifying a variable as face count. This face count is going to contain a string that will read the text faces, followed by the length of the list, in which is the faces we have detected successfully with our classifier. So, say we detected 3 faces, the length of our faces detected is going to be 3. So we can then put that as our face count on the frame, which we'll do with our put text method, where we specify the text to put as face count and we specify we want it on our frame. We're going to go ahead and position it in the upper left-hand corner of the frame, and we're going to draw it with our class constant font and text color and thickness. And the scale value we'll just specify as 1. Now we're going to go ahead and just print this to the console also so that we can have 2 interactive displays updating our face counts. And we'll end this with some exception handling in case anything occurs. We'll know that there was an error that occurred in this method. Looking to our detect faces webcam.py module, this is our entry point to performing our face detections over our computer's internal webcam. So as you can see here, we're going to import OpenCV to perform our image processing. And then we're going to import from our face detection package. And from the Frontal Face Detector module, we import the Frontal Face Detector class we just described. Following our imports, we have a function titled Detect Over Webcam. This takes in a video capture object and a detector, and within the function, we start a while true loop, which is an infinite loop as we want face detections to run. So within this infinite loop, we're going to go ahead and specify variables return and frame, and we're going to set them equal to cap.read. Return is a Boolean variable indicating whether the frame was read successful, while the frame variable is our actual frame received from our webcam. After getting our frame, we're going to call our detector's detect faces method on this frame. And after calling the method, we're going to go ahead and show the frame such that the method has drawn on the frame our face detections. Now, we're going to display this in a window titled frame, and following this, we have to use cv2.wait key with an argument of 1, such that our frames are updated with a delay of 1 millisecond. Now, our wait key is specified in an if statement, which includes this check for if our Q key is pressed. Now, we use a check for if our Q key is pressed such that we can break from this infinite while loop, can release our capture object, and destroy our OpenCV window. Looking at our main function, we initialize a variable called the Haar detector, and we set this equal to our Frontal Face Detector class so that we can get our Frontal Face Detector and use it to detect over our webcam. Now we also initialize our video capture object and specify with a parameter of 0 such that we can stream from our computer's internal webcam. Lastly, in this main function, we call our detect over webcam function and we pass in this initialize capture object and Haar detector. Then we have a dunder main which simply runs this main function when this script is executed.
Alright, so here I am in my setup. I've got my laptop with its internal webcam. We're going to be streaming video over to detect my face and my buddy Nikola Tesla's face. So without further ado, we're going to go ahead and run our detect faces over webcam module. You'll see the webcam immediately comes on and we get detections. Now, We lose our detections if we turn too far either way. And this has to do with our Haar frontal face cascade and how it performs detections. Now, we would do a better job of performing these detections using either the media pipe space mesh model or training a custom object detector to detect faces or people. But for such a simplistic approach and for such a quick loading and running program, this is good. Let's test over 2 faces. Okay, we can pick both of us up. And then I'd like to also maybe try letting in a little bit of light. See how this does. Well, maybe if the light was from the other direction. So let's try this from the other direction. There. Now, that's not much better, but it's an overcast day and we are detecting 2 faces. That's why I have this light here, because when I take it away, there was not nearly enough light. But as you can see, we're doing a good job. There's no face there, so get off. And that's that. We have detected faces over our computer's internal webcam using OpenCV and Python. And it's simple as that. Now, like I said, there's more improved approaches to this that would perform better detections, more accurate, better tracking. But this is a good start, and it's an important approach to learn. Thanks a lot for watching. And until next time, have a nice day.